Hello everyone and welcome back. This is my second video from my playlist Counting Techniques. Today we will be talking about permutations. I'll start with what are permutations, the general formula, permutations of subsets, and permutation of similar objects. All of them with examples and explanations. But before we continue, don't forget to subscribe to the channel and leave a comment down below on what topic would you like me to cover next. Without further ado, let's jump into it. So, what is a permutation? Let's say we want to find the number of ordered sequences of elements in a set. Let's consider, for example, the set S that contains the elements A, B, and C. A permutation of the elements is an ordered sequence of the elements. For example, ABC, ACB, BAC, BCA, CAB, and CBA are all of the permutations of the elements of S. The number of permutations of n different elements is denoted as the following: n exclamation, or what we'll call factorial. N factorial is equal to n times n minus 1 times n minus 2, and so on until we reach times 2 and times 1. In our previous example, with S equal to A, B, and C, we know that the cardinality of S is 3, so n is equal to 3. If you want to know more about cardinality, I have a video that covers all C theory, including cardinality. You can check it out above. Following our formula, the permutation of n will be equal to n, which is 3, times n minus 1, which is 2, times n minus 2, which is 1. Remember, we'll stop once we reach the number 1. So 3 times 2 times 1 is equal to 6, which is the number of ordered sequence of the elements in S. These are also called linear permutations. And this result follows the multiplication rule that we covered in our first video from this playlist. You can also check it out in the link above. Now, we're going to talk about permutations of a subset. In some situations, we're interested in the number of arrangements of only some of the elements of a set. The number of permutations of subsets of R elements selected from a set of n different elements is the following. Permutation of n elements in a subset of R elements is equal to n times n minus 1 times n minus 2, and so on until we reach n, which is the number of elements, minus R, which is our subset, plus 1. Now, let's do an example for permutations of a subset.
So now an example. A printed circuit board has 8 different locations in which a component can be placed. If 4 different components are to be placed on the board, how many different designs are possible? Each design consists of selecting a location from the 8 locations. So we're going to choose 4 different locations, 3 and 4. For the first component, we're going to have 8 different locations. For the second component, since we already chose 1 from those 8 in the first step, we're going to have left 7 locations. For the third component, we're only going to have 6 locations, because we already chose 1 for the first component, we chose another one for the second component, and for the third one, we're choosing another one. And for a fourth component, we're only going to be able to choose from our 5 different locations that we have left. So what we have is 8 times 7 times 6 times 5. That should be equal to 1,680 different designs. We can also do this using the permutation formula that we just explained, which is P as a permutation of n, choosing R, that is equal to n factorial divided by n minus R factorial. We know that n in this case is equal to 8 since we have 8 different locations, and R is going to be 4 since we're choosing 4 different components. Just replacing the values, here we have a factorial divided by 8 minus 4 factorial. That should be equal to a factorial divided by 4 factorial. And this is the same as 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And 4 factorial is 4 times 3 times 2 times 1. The 1 doesn't really matter. We're going to cancel 2 with 2, 3 with 3, and 4 with 4. What do we have left? We have left 8 times 7 times 6 times 5, which is the same as what we had before. That's 1680 different designs.
So what happens if some of our elements in our set are the same? This will be permutations of similar objects, and the formula is the following, where n is equal to the total number of options, n1 is the total number of option 1, and n2 is the total number of option 2, and so on. Is it getting a little bit complicated? Let's clear some things out with an example.
So now for this next example. A hospital operating room needs to schedule 3 knee surgeries and 2 hip surgeries in a day. So we're denoting knee and knee surgery as K and a hip surgery as H. The number of possible sequences of 3 knees and 2 hip surgeries is 3 knee surgeries, and for hips we're gonna have 2 surgeries. In total, we will have 5 surgeries. So from our formula, we know that n should be equal to 5 since this is the total number of surgeries. n1 is going to represent the knee surgeries. We know that we will have of them 3, and n2 is going to be our hip surgery. We have that n factorial divided by n1 factorial times n2 factorial. That should be equal to 5 factorial divided by 3 factorial times 2 factorial. And this is equal to 5 times 4 times 3 times 2. The times 1 I'm not gonna put it here because it's really not important. Divided by 3 times 2, and for 2 factorial is just 2. Here we're gonna cancel out some things. 3 goes with 3, and 2 times 2 is 4, so the 4 on top goes away. What we got left is 5 times 2, and that is equal to 10. So 10 is the number of possible sequences of 3 knees and 2 hip surgeries in a day. Here you can actually see the 10 sequences that we can get from hip and knee surgeries in a day.
And we have reached the end of this video. If this video has helped you, don't forget to subscribe, like, and leave a comment down below. Until the next one.